part, and then the rest we will do the other way, and it's a lot harder and long to the point I haven't yet clicked in my mind. It hasn't yet clicked, meaning I don't yet have a full understanding. I'm still a bit not seeing the wood, the forest, because it's too close to the trees, and you'll probably be the same. So this time for this board, for these, well, next 3 sessions after this one, concentrate on preparing yourself for the following board, the following 4 sessions, well, several sessions after these 4, to get the denouement, the outcome, based on all the preparatory steps that we'll do in these, well, the following 3 sessions. Okay? Right. So now we were at the end of the previous session. We were creating a new notation, a kind of shorthand, which is very convenient, that allowed you to just write down, to modify your transition rules in such a way, a kind of shorthand transition rule, that would allow you to write a whole string onto the stack. And then we expanded that shorthand transition rule into, well, the corresponding transition from one state to another state. We can expand that out into the usual transitions, series of sequence of transitions, where at each transition a single symbol is getting written onto the stack, because that's how a PDA works. But so we're using a kind of shorthand. So that's where we were. So here's the shorthand notation. So you're modifying your transition function delta, and you write it in the usual way. Now it's a transition function for a PDA. Okay, it's not a finite automaton. It's a PDA, push down automaton. It has a stack. Right? So this transition function will give you, depending on 3 things, so it's a function of 3 things in a sense, the current state, that's Q, A is the current symbol being read in the input stream, okay, and the S is the symbol at the top of the stack currently. Okay. Now, depending on those 3 things, what the current state is, what the current symbol is being read in the string, and what the current symbol is at the top of the stack, on the basis of those 3, the 3 parameters, if you like, in your function, transition function, that will map, it's a function, it will map into an ordered pair, which is here, and the first member of the ordered pair is the next state, okay, in this case R, and the second member of the ordered pair is a string. Now it could be just a string of just one symbol, that's possible, but this shorthand, this could be a general string, and what it's telling you, you interpret that this string here, this second member of the ordered pair that results from the transition function, that string gets pushed. Okay, you put the whole string on the stack, symbol by symbol. Right, so that's what's being saying here. Okay, so this transition function will give you, result in this ordered pair, next state, and this string here, put it on the stack. Right. So this. Oh, and by the way, this belongs to. Now look, it's a non-deterministic PDA. Okay. So the transition function, your delta here, it doesn't just give you an ordered pair. It gives you a set of ordered pairs. So if there's only one ordered pair that's giving, well, then there'll be wiggly brackets around. It'll give you a set with one member. But quite often it'll give you several ordered pairs. Now that's typical of non-determinism. I mean, go way back, earlier lecture. What is the definition of a non-deterministic automaton? It's one where it's possible to have more than one next state. Okay, it's as simple as that. So this delta function here will deliver. It will map to, or put another way, it's this function, transition functions domain range. Now range is a set. Will be a set of ordered pairs. So you could have, for different ordered pairs, you could have different next states, right? Non-deterministic, different states, and different strings that you're pushing onto the stack. Alright, so this transition function delivers, if you like, results in a set of these ordered pairs. Next state, string to be pushed. Okay, clear on that now? So if Q's the current state, A's next input symbol in your input string, and S here is the symbol on the top of the stack, then what does the PDA do? It can read the A, so it's reading the A from your input string. It pops the S, okay, and then it pushes the U onto the stack. So it pops the S, pushes the U onto the stack, and then switches state from Q to R. Okay, goes to state R. So here's a single transition. It might be a part of a transition diagram, a state diagram, or a state transition diagram. Okay, and the label is now, instead of having a single symbol here, like we've done, and that would be when you push a single, one symbol onto the stack. But now we've got a string. You could write a string here, whatever it is. Now remember from previous sessions, the label here for the transition for non-deterministic PDA is some symbol, comma, symbol, arrow, symbol. That's what we had. But now the third symbol here is actually a string of symbols. So the A here is what you're reading in the, it's the symbol to be read in the input string. Your S is the symbol at the top of the stack, and this is the string you will push if these match. Okay, so if what you're reading in the string is A, the symbol, and if the top of the stack's symbol is S, then pop this S, push this string X, Y, Z, and go to state R. Okay. Now this arrow here is just a way of saying this diagram, this state transition, just a single transition, just from Q to R. This diagram is shorthand for what's really going on, which is this. Okay. Now these states are like extra supplementary states, and they get used in the shorthand because see when you're pushing this string, in reality because this is shorthand, you're pushing a symbol at a time onto the stack. Okay, now it's a stack, so first in is last out, or last in is first out. Right? It's LIFO or FILO. That's the nature of a stack. So things get reversed. So if you're going to push stuff, push from the right hand end, moving towards the left. so that when it comes out in the order that you want, not reversed. Right? It's a stack. Okay, so this is shorthand for this stuff. This is shorthand diagram for this transition diagram. Okay, so now we'll create some. We'll add some extra auxiliary, supplementary, whatever states to. What is it? Q? Yeah, big Q. So states. Right? So we add for this particular case, we'll add 2 more states, so that we'll transition from Q to Q1, and then from Q1 to Q2, and Q2 to Q2 to R. Right? And at each transition, so here we've got 1 transition, here we've got 3, because our string has 3 symbols in it. And here we are pushing 1 symbol at a time. So this is shorthand for this. Right? Now, okay, so we start, we're reading A, just like here, and S is at the top of the stack, so we'll pop the S and we'll push the Z. The Z, not the X. Okay? So we're starting here, going backwards, because we're putting it onto a stack. Right? And then we will ignore the inputs string, we will ignore what's at the top of the stack, and we will push up the Y, the middle one here. Okay? So what's on the stack now? Y, and under it is Z. Okay? And similarly, and then transition